Welcome to my Engineering Challenges 1 video presentation. Today I will be talking about the most frequent natural disaster being earthquakes. What are earthquakes, you might ask? Well, an earthquake is the shaking of the ground due to the sudden movement of tectonic plates within the crust. Earthquakes happen along fault lines where tectonic plates meet and grind against each other. When too much pressure builds up, the tectonic plates shift and break suddenly, releasing massive amounts of energy causing vibration. We can measure the intensity of earthquakes by the Richter scale. The Richter scale measures the amplitude of seismic waves recorded by a seismograph. One recent seismic event was the earthquake in Chile. The 2010 Chile earthquake struck on February 27, 2010, with a powerful magnitude of 8.8 on the Richter scale, making it one of the strongest ever recorded. It caused a widespread of destruction, damaging and destroying over 1.5 million buildings across central and southern Chile. Around 525 people were killed, 12,000 were injured, and 800,000 were displaced from their homes. The earthquake also triggered a tsunami that devastated several coastal towns, adding to the severe impact on the country. In our Engineering Challenges module, we researched about two main types of engineering: structural engineering and geotechnical engineering. Structural engineering. We modeled a residential building based on Alto Rio. We did this to investigate and to determine which aspects of the building caused the collapse of the building. In this model, we use spaghetti to simulate structural elements like beams and columns, blue tack and tape for connections of structural elements, and an envelope for our foundation. During the shaking test of our structure, it failed due to our connections our connections between structural elements not being strong enough to handle harsh vibrations, leading to its collapse. Geotechnical engineering. We made a model using sand to investigate the seismic slope stability of soil. We calculated the geometry of the soil before and after the impact from the vibration. We then measured the acceleration using an app on our phones. We repeated this for different loads as well. The data was then used to plot a graph of the angle of repose against the acceleration. Using this, we could determine the factor of safety. If the factor of safety is less than 1, then it's unstable. However, if the factor of safety is greater than 1, then it's stable. To conclude, earthquakes are powerful natural forces that test the strength of our structures and resilience of our communities. The 2010 Chile earthquake highlighted the vital role of structural and geotechnical engineering in designing safer buildings and foundations to withstand seismic events. And the one thing that we should always remember is that earthquakes don't kill people, but our construction does. Thank you.